Welcome back to Chemistry 12, Chapter 5, Lesson 5. The fourth class of the nitrogen organic compound is amino acid. By the end of this lesson, students should be able to define, classify, names, and write the chemical and the physical properties of the amino acids. Now, what are the amino acids? Alpha amino acids are a carboxylic acid in which one hydrogen atom of alpha carbon is replaced by amino group. Now look this one, carboxylic acid. Okay, this is alpha carbon. The alpha carbon, it is the carbon that attached to the C double bond OOH. If you replace one hydrogen atom by the amino group, we will get alpha amino acid. So in this one, this is as example, it is acetic acid because you have two carbon atoms. This is an carboxylic acid. And its name is ethanoic acid also because ethane, because you have two carbon atoms, and wick acid, it is for the acid. Now here I replace one hydrogen atom by amino group. That's why we call it alpha amino, and this is acetic acid, or it is the same alpha amino ethanoic acid. And it has the common name or the general name, we call it glycine. Now, amino acids have two functional groups. The amino group as a basic character, and the carboxylic group, it is acidic on the same carbon atom. So you can write it in many ways, maybe like this way. This is R, it is alkyl group, and this is carbon, you call it alpha carbon. It attached to this COOH. So this one, we call it carboxyl group, and this one, it is amino group, it is NH2. Also, you can write it in another way. So this is alkyl group. You can put NH2 up or down, no difference between them. We have this alpha carbon. It is the carbon that attached to the C double bond OOH, and you can write it COOH, and here it is the same R. So in this case, the alpha amino acids, it means amino group on the carbon number alpha, or we call it alpha carbon. Now, what are the types of amino acids? There are 20 types of alpha amino acids required in the building proteins. We have the first one, they are essential amino acids. Here we have 8 types of essential amino acids. We call them essential amino acids because they cannot be synthesized by the body. So they have be taken from the food containing proteins. They are very important for the growth of the body. They are found in high amount in the animal proteins. The second type, we call them non-essential amino acids, and we have 12 types. They can be synthesized by the body. That's why we call them, they are non-essential. You take them or you don't take them, your body synthesizes them inside it. Here we have, what is the important for them? They build up the tissue proteins for the body. Now, the classification of amino acids. Amino acids can be classified into 5 types according to the NH2 and COOH. The first one, if we have monoamino monocarboxyl, it means I have one carboxyl group and one amino group, mono. So we have 2 types of them. We have alanine and glycine. Just they have the same figure, CNH2 HC double bond OH, and this one, it is the same CHNH2 COOH. If the R is hydrogen, we call it glycine. If you change this H to CH3, we call it alanine. Now it is amino group is a basic group, and this is carboxyl group, it is acidic group. One base, one acid, so they are neutral. So they are not affected on the litmus paper. The second type, it is monoamino dicarboxyl aliphatic amino acids. Here we have carboxyl group and here we have another carboxyl group. So we have dicarboxylic group and one amino group. So we call it monoamino dicarboxyl. This one, it is the same for all amines, CH, NH2, COOH. For all amino acids, it is the same. But the difference here for the R, if you have CH2, CH2, or COH, we call it glutamic acid. If you have only CH2, COOH, we call it aspartic acid. Now we have two carboxyl group, that's why they are acidic. So they turn litmus paper red. Now, the third class, it is diamino monocarboxyl aliphatic amino acids. Diamino, like this one, we have NH2 and NH2. But we have only one COOH. So, and this is the same. We have NH2, NH2, diamino, and one carboxyl group. This one we call it lysine, and this one we call it arginine. Because we have two amino groups, so they are basic. So they turn litmus paper blue. Now the fourth type, amino acids containing sulfur. We have two types here. If we have this one, we call it thiol group, SH, or the sulfide group, this is S. In the first one, we have CH2SH, so we call it cysteine. Here we call it methionine. So all of them containing this S, it is sulfur. Now, the last type, it is aromatic amino acids that contain the benzyl ring or cycle compound. We have two types here. This one we call it phenylalanine because this is the phenyl group and this is the alanine. Here we have tryptophan. Now, the physical properties of alpha amino acids. In the physical properties, most of the alpha amino acids are crystalline solid with high boiling point and melting point. The simplest amino acids, the melting point of the glycine is 250 degrees Celsius. The first member of the alpha amino acids, the glycine and alanine, are highly soluble in water, but less soluble in the organic solvent. They are not affected by passing the current in the neutral solution. Why? Because they are present as a dipolar ion. Look, this one, RCHNH2COOH. This is acidic group and this is basic group. Now, this N, it has pair of electrons. Now, this pair of electrons take this H because this is a base, reacts with acid, enter the same molecule. Now, when this H transfer to NH2, we will get NH3 plus because losses of electrons, and this one it gives COO minus. Here we have positive ion, and this is negative ion. We call it dipolar because we have positive ball and we have the negative ball, so they don't attract to the anode or to the cathode by passing the current, so they are not affected by passing the current. But here we have neutral solution. But if we add acid to the neutral solution here, now this is the neutral solution. We have positive ball and the negative pole, so we call it dipolar. If we add acid, it means you add proton. So this is positive from the acid in the acidic solution, goes with this negative pole, so it becomes, COOH. Now this compound has the positive pole. In this case, because it has a positive ion, so they are affected by passing the current, and amino acid migrate to the negative electrode, and the negative electrode, we call it the cathode. Again, for this point, in the acidic medium, so the alpha amino acid is present as positive ion. That's why it goes to the cathode. And also in the basic medium. In the basic medium, by adding strong base, such as OH or NaOH, so in this case, look, this is in the solution, in the neutral solution. It has positive and negative. But if you add OH or a base, this is strong base, this OH takes H from NH3 and are removed as H2O. Now we have this end, it is negative. So in the basic medium, amino acids are present as negative pole or negative ions. Negative ions, if you pass the current, so in this case, they migrate to the anode because the anode is positive and this is negative. So negative attract to the positive. These are about the reactions of amino acids. As I said, amino acid, it has two functional groups. Amino group as a base and C double bond OOH as an acid. So the reaction of the amino acids, we have 4 types of reaction. Reaction for the carboxylic group, reaction for the amino group, and reaction for both, and we have the amphoteric properties. I will start with the first one. The amino acid reacts as a base. It means as amines. So here it is NH2 group reacts with acid chloride or acid anhydride or carboxylic acid. The same as amines. The reaction here, if you have acetyl chloride with glycine, so you have to remove this Cl from the acid and 1 hydrogen from the amino acid. 1 hydrogen from here and Cl are removed as HCl. What are remaining here? CH3CO. So this is CH3CO. You have to connect NH, then NH, CH2COOH. So as amine, you have to remove 1 hydrogen atom from the NH2 and Cl from the acid chloride, or OH if you have acetic acid, so they are the same as amine. The second reaction with nitrous acid, forming hydroxyl acidic and nitrogen gas. The general rule for the nitrous acid, you have to remove NH2 and replace it by OH as amines. So with amines or with amino acid, the reaction the same. Just replace NH2 by OH and we have the side product as a nitrogen. And this reaction is very important in our life because this reaction is used to analyze protein to determine how many nitrogen inside it and to distinguish how many amino acids inside this protein. Now, the second type of the reaction, not for the amino group, it is for the carboxyl group. We have 2 types of reaction. With alcohol to give us ester. So here it is, the amino acids, glycine. This is alcohol, we have OH. Now, from the alcohol, you have to remove this H with OH from the acid. Now, they are removed as H2O. This is an acidic medium. So what is the remaining? It is NH2CH2CO, and here we have OCH3. So from the alcohol you have to remove H, and from the acid you have to remove OH and join the rest of the compound. The second reaction, it reacts with barium hydroxide. Barium hydroxide is BaOH by 2. The general rule, this is the amines, RCH, C double bond OH, NH2. You have to remove C double bond OO by barium hydroxide in the presence of heat. Just remove, this is C double bond OO, or COO, it is the same. They are removed as CO2. What remains here, it is RCH2NH2. Why we have CH2 here and this is CH only? Because you have to remove C double bond O, and this H, attached to this carbon atom. So we have RCH now 2NH2. This is examples for the alanine. Here we have CH3, CH, COH, NH2. When you find BaOH by 2, okay, just remove COO and write the rest of the compound. So I remove COO as CO2. Then what we have here, CH3CH, CH3CH, and here we have NH2. This one we call it alanine. So we will get ethylamine, and this is one method of preparing of amine from the amino acid. Now the third type of reaction, both the NH2 and COH react in the same time. They react with any ions such as the copper ions here and forming salts. And if you have two amino acids react with copper ion, we will get deep blue color. The compound like this one. So this is glycine. Another glycine react with copper ion. They give us this compound. We call it the copper glycine. Now the last reaction for the amino acid, it is the amphoteric properties. What does it mean, amphoteric properties? Amphoteric properties means if you have a compound, it has two functional groups, one of them acid and one of them is base. So they react with acids as a base and react with base as an acid, forming salt. Here we have the first reaction with hydrochloric acid. So here we have NH2 as basic group, and this is COOH as acidic group. So they react with acid first. Now here we have, look, this is in acidic solution. In the acidic solution, so amino group will react. Here we have NH2. This NH2 take one hydrogen atom and give us NH3 plus, because the pair of electrons are lost here are joined with with hydrogen atom, and the rest of the compound CH3COOH, and here we have the negative chloride ion. You can write it at the end of the compound or beside this one. So this is the right question, because look, we have acid, so acid react with a base, but unfortunately in the book it's written in a wrong way. This is in the book, in the ministry book I talk about. So it's written like this one. This is acid group. Okay, he reacts with what? With the acid group and give us this compound. But this compound, it's wrong, but we have to follow it in the ministry exam. But this is the right one. Now the last reaction with sodium hydroxide solution. With sodium hydroxide, this is base, and also this is acid. So acid group reacts with the basic group. You have to remove H from the acid and OH from the base, H and OH as H2O. What remains here? It is Na, it's replace H and give us this compound. And here we reach to the end of this chapter. Thank you for listening.